Hey everybody, Professor Hyman here. Going to talk about hypotheses, but before we talk about hypotheses, we want to talk about the research question. And before we talk about the research question, which drives your hypotheses, I'm going to talk about terms just briefly. There are other videos that cover this in this section and other sections of the course, but this is crucial that you know this. What do you have on each side of the equation for regression equations is you have a set of independent variables and one dependent variable. And here's the definitions. First of all, we abbreviate independent variable IV for independent variable and dependent variable for DV. Okay, and I've written right down here that this is item 0 here. DV, the dependent variable, is the outcome. We want to predict this. That's what we're doing with the dependent variable. And the IV is the cause. So you have a cause, which is the independent variable, and that is hopefully, you're testing whether it gives you the outcome. Okay, so you have a hypothesis that says this outcome is caused by these factors or this factor. So another way to say it, this dependent variable is a result of the effects of these or this independent variable or variables. Okay, so again, independent variable cause, dependent variable outcome. Now we're going to jump up here to number 1 from item 0, and this is going to be the research question. Okay, so the research question tells us the dependent variable only. A hypothesis tells us both the dependent variable and the independent variable, the IV. Okay, now the format of the research question should always be consistent, and it really just takes a very simple form. What factors determine fill in the blank with your dependent variable? Here's an example dependent variable, okay? Passion for ice cream in Japan. That would be the dependent variable. What factors determine passion for ice cream in Japan? Again, the thing you're trying to predict, in this case I'll be even unpack it a little more, is the degree of passion for ice cream in Japan. Okay, maybe Ben & Jerry's is thinking of entering Japan, and they need to know what causes people to love ice cream in Japan. So their research question is, what factors determine passion for ice cream in Japan? Question mark. I'm going to add the question mark here. It's right here too. Okay, that's item 1. Let's jump to item 2 here. From the research question, which I said in item 1 tells us just the dependent variable, we jump to hypotheses. A hypothesis, which is the singular, tells us both the dependent variable and the independent variable in one sentence. Okay, so what is it first? There's definitionally. The hypothesis is more than a guess. Okay, a lot of books and some of the videos say that a hypothesis is your guess. If you want to use the word guess in hypothesis, you would say it's an educated guess or an informed guess or a guess that exists in some context. Better way to say than an educated guess or assertion is to say that it's an assertion based on a theory. Okay, and a theory is a systematic belief that cause and effect work a certain way. Let me correct this here. There should be a K there. Again, theory is a systematic belief that cause and effect work in a particular certain way. Okay, so now let's look at some types of hypotheses. Item number 3 up here. So we have 3 different types of hypothesis. Okay, we've got the null hypothesis, which is abbreviated H0. We've got a non-directional hypothesis, which I'm calling H1. I could call it H2 if I wanted. It's just the null is the only one that gets the 0 designation. And then we have a directional hypothesis, which I'm just, for this example, I'm calling H2. Okay, so let's have an example of each one really quickly. The null hypothesis simply states that nothing is going on. It's just not happening. Okay, and an example of that would be weather has no effect on ice cream sales in Japan. In other words, that's the null hypothesis. Our goal is always to disprove the null hypothesis in regression. Okay, now that one, you can disprove it by showing that something else is going on, that there is actually an effect, a significant effect, that one of the independent variables matters, okay? And we call that significant, which we'll get to in a different lecture. So now that's the null. We want to disprove the null. A non-directional hypothesis is quite simply the idea that there is an effect, but we don't know how it works. But we say that an effect exists, and weather has an effect on ice cream sales in Japan. Good example of a non-directional hypothesis. We don't know what kind of effect weather is having on ice cream sales in Japan. We just think it has some kind of effect. In business, economics, social science in general, we don't typically test non-directional hypotheses. You can do it, but it doesn't add a lot of wisdom or value to the knowledge base of the world when you test non-directional hypotheses. So we don't prefer these. They're out there and we can test them, and there's reasons to test them sometimes, but we'd rather test directional hypotheses, especially in our line of work, which is going to be survey research. A directional hypothesis says there's not only an effect, but the effect has this character. And so as an example of that, as the weather gets hotter, ice cream sales in Japan increase. So as the temperature goes up, the ice cream sales increase, okay? As A goes up, B goes up. And then along with that, you would get, as an extension, you could have said the same hypothesis by saying, as the weather gets cooler, ice cream sales decrease. These are not two different hypotheses. As it gets hotter, the sales increase. As it gets cooler, the sales decrease. You can state it either way, but you're actually stating the same hypothesis. You're not stating two distinct hypotheses. To get two distinct hypotheses, you should say something that is a different independent variable with the same dependent variable for a particular research project. So for example, instead of the weather getting hotter, we could say in the big cities, people prefer ice cream. So we would say a hypothesis on the lines of people who live in the largest cities in Japan tend to eat more ice cream than people who live in smaller cities and towns. And that's another directional hypothesis that's empirically tested, testable. You can test it with data, okay? Let's jump now to item 4 to wrap this up, to close out this brief video segment. In this class, we're working with directional hypotheses, as I said, directional. These are hypotheses of association, directional hypotheses of association. Big mouthful. What does it mean? We're saying they're hypotheses of association rather than causation or causality. They are not related to causality in a statistical sense. Okay, in other words, we're not saying that the weather causes ice cream sales to go up. What we're really saying is there's an association between hot weather and the increase in ice cream sales, to go with my directional example here. Now, we often and frequently infer causality. Okay, again, looking at H2 above, as the weather gets hotter, ice cream sales in Japan increase. It's not a big leap to say that, well, we've established there's an association between hot weather and ice cream, and it's probably also a relationship of causality, but regression just on its own does not test causality. It tests for association. So you have to be a little bit careful. Since it's a directional hypothesis, you get the direction of the association. In other words, it's kind of absurd to think that as ice cream sales go up in Japan, the weather gets hotter. That makes very little, no sense. Okay, so that's how we get from the statistical method is actually measuring association, but we think it's reasonable to claim causation or causality, that weather is causing some effect on ice cream sales in Japan. And so we kind of make that leap in the paper, but statistically, mathematically speaking, we're not actually testing for causality. We'd like to test for causality. This is a simple way to test for association, and then we infer from this that causality is probably what's going on. Okay, so that's the entire lecture. Let me just recap it really quickly. I'm going to start back from 0 here. Dependent variables are the outcomes. We abbreviate them DV. We want to predict the outcomes. Independent variables are the causes. They're what lead us to the outcomes. They have effects on outcomes. And then the research question takes the format of what factors determine fill in the blank. In my case, our example was passion for ice cream in Japan. And then we have hypotheses, which are generally based on some kind of a theory, which is a belief that cause and effect are working in a certain way. And then we have the null hypothesis, we have non-directional hypotheses, and then we have the hypothesis type that we're working with mostly in this class, that I'm training you on in this class, and that indeed most research is associated with this type of hypothesis. And that is a directional hypothesis. As A goes up, B goes up. As A goes down, B goes down. Those would be the same hypothesis. Similarly, as A goes up, B goes down is the same as A goes down, B goes up. Okay, that's it for now. Covered a lot of ground in a very short video here. I hope you enjoyed it. I sure enjoyed putting it together. I'll see you in the next video. Thanks very much.